Welcome back to Three Inquisitive Kids. Now we're going to continue our journey of studying for AMC8 by looking at the next type of problems, counting paths. Counting paths is a category of problems that have come up very often in the past few AMC8 tests, and it usually consists of something or someone traveling from one point on a coordinate plane or some sort of grid, geometric grid, to get to this final destination. And it's usually going to ask you how many different paths are there to get from one point to the other. Let's look at a very simple example of what I mean. A rabbit is walking in a coordinate plane and has to get from 0, 0 to the carrot at the point 5, 5. If the rabbit can only move 1 unit up or 1 unit right at any given move, how many ways are there for the rabbit to get to the carrot? Let's first draw this out so we can better visualize it. Say this point right here is the starting point, 0, 0, and our rabbit is starting from this point. And I'll just use the grids on this graph paper to help me draw it out. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This would be the point in the final destination where the carrot is at, 5, 5. Now we can basically try to count all the different ways to get from 0, 0 to 5, 5, traveling along the lines in this coordinate grid. This is basically what we're trying to figure out. Okay, but it's going to be super tedious if we try to count every single possible step. So how do we start? Well, whenever we're met with really complicated or long or tedious problems like this, it's not necessarily complicated, it's just tedious because it requires a lot of work. Whenever you see problems like this, I usually like to tell myself that there's always a solution, and the solution is usually going to be a pattern. So here we are traveling from 0, 0 to 5, 5. Let's first break it down and try to see what would be the answer if it was 0, 0 to 1, 1. This is 1, 1 and 0, 0. Well, we know that we can only be traveling along this square. We can either move up or down. So we could go this way or we could go this way. Those are the two ways. So I'll here write two ways. Now let's see what would happen if we did it from 0, 0 to 2, 2. Well, we're traveling along these lines here, or even in the middle. Let's first look at this point right here. The only way we can get to this point from the origin point is if we go up 1. So there's one possibility that the rabbit will land on this point. Now, what about this point right here, this corner? The only way for the rabbit to get to that corner is if it traveled up 2 times. So there's only one possibility for the rabbit to get onto that point. Now if we look at this point right here, the only way for the rabbit to even get to that point is if we travel 1 unit right from the origin point. So there's one possibility for that. Now I'm just writing the number of possible ways to get to that point as if that was a destination next to each point. So each of these numbers, these number ones, represent the one possible way for the rabbit to travel there. Now this corner point right here, the only way you can get there is if you travel right 2 times from the origin point. So there's a 1 next to that point as well. There's one possible way for the rabbit to get there. Now this is when it gets interesting. This middle point right here, how many different ways are there for the rabbit to get there? Well, there's 2 different ways. There's one way if we go this, and one way if we go right first and then up. So there's 2 ways to get to the middle point from the origin point. And you can see that this is a pattern because what we essentially just have done by writing down the 2 is adding the 2 numbers that led up to it. So adding 1 and 1 gets us 2. Now we do the same. How many different ways are there to get to this point? Well, all we have to do is add 1 and 2 to get 3. Here, all we have to do is add 1 and 2 to get 3, and then finally 6. So there are 6 ways. As you can see, we don't have to continue all the way to do 3 and 4, because we already figured out a good solution to solve this type of problem. All we have to do is write down the number of possible paths to get from the origin point to one particular point on this entire plane. And then after adding it all up, we'll finally get to the destination 5, 5. So let's start from the sides. We can start by going up. From the origin point to this first point right here, there is only one way, and that is by going up. Same thing with all these on the sides here. These are all one possible way. Same on the bottom. There's one way to get from the origin to these points, only one. Now what we can do is start adding. So in the middle, we add 1 and 1, which is 2. Now we add 1 and 2, 3, 1 and 3, 4, 1 and 4, 5, 1 and 5, 6. And as you can see, this is going to be somewhat symmetrical because, it's the same numbers on both sides. So here it'll be 3, 4, 5, 6, and then we'll move up. So 6, 10, 15, 21, 6, 10, 15, 21. We keep adding. 70. And now we have, right here, we're going to add 70 and 56, which is 126. And here we have 126 as well. So we're going to add 126 to 126, which gives us 252. So there are 252 different ways or different paths the rabbit can take in order to get from the point 00 to the point 55, while under the condition that the rabbit can only move 1 unit up or 1 unit down, or 1 unit up or 1 unit right.